Hello, guys. David Vos here. Boy, it's a beautiful day. Sun is shining, and I'm just on cloud nine. And guys, I hope you're having a wonderful day. Well, I think I may have discovered something here. This may be the biggest revelation I've ever had, or it may just be a flop. But we're gonna work our way through it. And I think it may take 2 videos to do this, and I think it's gonna be worth it for all of you people who are either a flat earther or interested in the shape of the earth or such, you know, goings ons and talkings and conspiracies that we've been through lately. And it's always been strange for me to think that there's so many of these calculations that no one ever does. Right? Like, I when I was younger, I used to believe, I didn't know that scientists were saying they knew how far the stars were simply because of geometry. I really thought that maybe they somehow determined, because of the sun coming up on the horizon at a certain equinox or solstice or something, and measuring the apparent distance, and and timesing and the angle by the where the moon is, or what, somehow they could figure out these stars where they were. Although I thought, wow, that would be quite a task, but somewhere in my little mind, no one ever said, I never heard anybody say, oh, we know how far the stars are because of this and that, or, it just, obviously I knew they didn't travel there and measure the distance. Everybody knows that. But yet every scientist apparently knows that this star is this far, and this star is that far, and this star is that far. The moon is 240,000 miles away, and the sun is 93 million miles or something. And they all just assume that, well, all the calculations have been done by very important people, and we just know this is true. Now, I suppose a scientist knows that they didn't use geometry or calculus or anything to come up with these distances. I don't know. Maybe they did, but they never talked about it. As long as I was growing up, I never heard anybody telling us all of the particulars of these things. But, I wouldn't be surprised if the scientists are so stupid they just never even thought about it. Like, there's so much to know. Even if you're the greatest mathematician, you may just not have ever heard why supposedly we know. Now, other scientists, obviously, at least in modern times, I've heard them talking about the fact that, I looked it up, right, on AI, and they said, well, no. The reason we know how far the stars are is because of the apparent, like, brilliance of a certain star compared to the brilliance of another star. But I'm like, wait a minute. If that star is closer, it's going to be more brilliant if they're the exact same size and the same, uh, watts or whatever of light. I mean, I couldn't see the reference points or how possible it could be. I mean, since of course some stars might be blocked by gases or apparent, you know, uh, pulling of the light, refracting off of a planet, or all these variables that no one could determine. So I came to the conclusion not very long ago that it's impossible for them to know how far the stars are. And then on top of that, we've been discussing lately about the fact that, according to the scientists, the space, we're using that word lightly or loosely because I don't believe there is any space, because we're using that word improper. I think people believe that there is space regardless of something filling the space. If somehow there could be empty space. And we've talked about this vacuum of space. And scientists say it with a straight face. They say literally there is a vacuum of space, and if you press them, will say, yes, there's no temperature. There would not be any, dust particles or anything in that space. It's a vacuum, meaning it's collapsed. There is nothing. The two sides of the balloon are collapsed. And between those two sides of the balloon, they're touching each other, the two sides. So there is nothing in there. It's completely nothing. So everybody knows that you can't measure the distance in something that we're going to say is no distance. right? There is no space because it didn't fill it up. That empty space is only theoretically empty only because there happens to be two sides of the balloon that you could start pumping air in there, and then this apparent area where there was no area, where it was flat and nothing in there. Now we're putting something in there like air, and now you can blow it up to a certain dimension and say, okay, there's space. However, the vacuum of space would mean no space. And so this is the other argument that we've been talking about, how I cannot believe or understand how they are going around saying these things. And scientists who are supposed to be so smart don't realize that a vacuum of space is nothing and cannot be measured. And therefore, there is no distance between us and a star if it's a vacuum of space in between. Now, nobody could imagine that these two stars out there at an angular distance, at some, there's some distance apart. We don't know how far away. That's part of the geometry that we don't know. But if we held a ruler 2.5 feet from which is about the distance of our arm, out, between our line of eyesight and those two stars, and measured the distance, we could say, oh, it's an inch or 2 inches or whatever. And wouldn't we then be able to judge the distance by saying 2.5 meters or, feet? And that would be one of the required, information data that we could calculate the distance. However, in geometry, you need two measurements. You need A and B. You need the measurement of A and B, which is only one distance. And then you need the angle. And then you can get the distance to another location. So, in other words, there is no way, because we would only have one distance. We could only have approximate distances. Perhaps if we could figure out by the fact that the moon is over here in the fall or at certain parts of the month and it goes over there, and we could see there's quite a bit of distance. But again, we wouldn't know how far, because we don't know actually, even though they tell us. We would have no calculations to figure out how big the moon was, how wide it was, how far it was. So that part of the geometrical equation is not there. Now, I know some of you are following me, and others you're thinking, okay, this is really getting boring, and you've done this before, Dave, and we don't want to see this. But friends, especially you flat earthers, man, pay attention. I am about to share something with you. It's going to blow your living mind. I think, unless I'm completely insane, which that could be too. But starting off with that in the background, last night I was thinking, while I was talking to Paul on the phone, and I had this revelation, and I was thinking about the fact that whenever, like flat earthers will say that the sun doesn't actually go down over the horizon because it's an infinite plane, or it's a much larger flat disk, but it's flat. And therefore, it's not going over the horizon. Many of the flat earthers believe that the sun literally goes around the disk above it, like a ball on a tether, like a tether ball going around the pole. So it's going like in a corkscrew. Maybe it winds up all the way top and then comes back. Well, that would mean that the sun's being, held up by a long string or rope or somewhat. It'd have to be some pretty heavy cable. But anyway, that doesn't make sense. And so the whole science of why this ball is tethering around just like that, of course, it could still be like we understand the kind of physics that we use in modern science, where we say, oh, well, there's gravity, and gravity is a force that is something that is the accumulation of all these different speeds and forces and powers and blah, 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 blah. And we talked about the barn door opening and the sun coming through and the dust flying and the swirling and the little vortices and the nucleus of dust particles, and how that relates to the positive, negative, postulation that, or apparent, reality that everything has two poles. Apparently, our Earth has two poles, and they're saying it's a globe. So whether it is or not, it appears to be even admitted by some of the greatest scientists like Santos Bonacci that, that there's a torus field, this is a fact, even to flat earthers. So you get a positive and a negative, or high pressure and low pressure, and it creates this vortex, I call it. They're calling it a torus field, but, probably because Taurus starts off the whole, thing, but right after Aries, the first age in the circle is the Taurus, and maybe it's a torus field. But I digress. The point is that this, for whatever reason, that things are moving. Okay, we're not talking about that today, but only to say that maybe this thing flying around above us isn't going around a globe coming up in the east and going down in the west, but it's actually, we're on a flat disk. Maybe it's infinite, maybe it's just a finite disk, but maybe it's a flat infinite plane. Either way, we don't know at this point, and it's not important. Let's just say it's a flat eternal plane. Well, if you looked in the distance on a flat eternal plane, you will definitely see everything getting smaller at the horizon. So a mountain that's 10,000 feet tall will look to be like 1 inch 50 miles away. Right? Now, that's the apparent look, right? From our perspective. AI keeps wanting me to know that's not accurate, that's impossible, blah, 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 because it's actually, still 10,000 feet, regardless of whether it looks to be an inch. And I'm like, okay. That's not what I want to know, is how far it actually is, because we already know how actually big that mountain is. We've got the altitude, it's 10,000 feet, Dave. Okay, but what I want to know is the apparent size. And they're like, okay, yeah. They finally admitted that, yeah, you could measure the 1 inch if you used a ruler at 2.5 feet away from your eye, and and they went through this whole thing. So obviously then, the horizon, if the sun is going on an infinite plane away from you, towards the west, at some point, even if it's an infinite plane, you would no longer be able to see the sun. Why? Because it goes to a place where it's even beyond that 1 inch, and somewhere it converges over the horizon, and you no longer really can see it, because that sun becomes so small, that little globe of the sun, or the circle of the sun, becomes so small, a tiny speck, that you cannot see it anymore. And I want to know how far away it would have to go on a plane before you wouldn't be able to see it anymore. And I wondered why no one had ever really calculated this, because if you think about it, if you could calculate that, then and that particular distance turned out to be exactly how far the Earth is supposed to be as a globe, then one might think that perhaps the globe's just an illusion. Because if you were looking in one direction and the sky converged, at a point in the distance, and the ground converged at a point, at the same point they converged in the distance, and that point is called the horizon on a flat plane, what about the fact that your vision on both sides, left and right, is also converging at the same point? Because the mountain 10,000 feet high is no longer 10,000 feet, apparently, but looks like an inch. However, the width of the mountain could have been 10,000 feet as well, or more. And yet it also appears to now be only an inch wide. So we've got length and breadth, width, and actually infinite numbers of degrees in a circle, because from where you're standing, everything in your spherical, sphere of sight, because peripheral sight is what we have. So therefore, when we look out, we see a certain distance up, a certain distance down, a certain distance right or left. And that then would be a circle, or a peripheral vision. So we're looking out perpendicular at a sphere that we can see, that we are aware of. The top is up in the sky. We see the sun, and we see, moon or whatever's up there, clouds. Down is the earth, right? And right is Australia, and left is Alaska or something. So, but we can't see all of that. But the point is, whatever our vision can see in front of us, we call it 360 degrees peripheral vision. Well, everything in that 360 degrees peripheral vision that we're seeing right up close. We can, there's a certain, if you don't move your eyes and just look straight, you can only see certain distance up, down, left, and right. But it's still a sphere. But we can only see, we don't move our eyes, we're looking straight. But now if we move our head, angle our head, imagining we're the center of this infinite plane, we move our head just 1 degree. And again, we have peripheral 360 degrees, but now the center of our peripheral vision is moved by a degree, meaning that from the center, looking up, left, right, and down, we can see everything in a 360 degree spin on a longitudinal plane, a latitudinal plane, and 360 different degrees or planes. We can see this not only standing in one direction, but if we moved 1 degree, we could do it all over in another degree. This would be 360 times 360, whatever number that comes out. And this is all that we see. And yet everything that we're seeing converges at some particular distance. And I got to thinking about that, and I thought, how interesting, because in my mind, I'm thinking that would mean that an infinite plane would appear to be a round ball from my point of view as I look at it. And the sun would appear to be going down over the horizon when in actuality it may just be going so far into the distance that I no longer can see it, and it looks as though it's going down over the horizon. Now, this is the argument that some of the flat earthers had. Of course, it's speculation because we don't know. But what if we could use mathematics and somehow prove any of this? What about the math that I just talked about, where there should be some, like, how people say that, the sun would go down over the horizon a few miles away from your vision if the Earth was 24,000 miles around. Then there's a calculation that they do whereby they can determine how far something at your altitude would drop down over the horizon. And it's not very far, and we shouldn't be able to see very far, yet people are looking far into the distance with these zoom lenses and so forth. And there are people like, what's going on? So I was thinking, okay, like flat earthers, what if this thing does go on much larger? Maybe it's not flat, maybe it's not infinite, but could we calculate just how far this sight goes? And if all of this can be measured with your arm stretched out 2.5 feet with a ruler, and we could see the apparent size of the sun or the locations of the sun setting, depending on what season and so forth, we should be able to use this information in geometry and literally decide how far it is that we can still see the sun, or ought to be able to see the sun, right, in the distance. And then we should be able to say, well, now, let's say that we find out that we should be able to see the sun in the distance for 6,000 miles if it's an infinite plane. And it turns out that is the same distance that it works out in math when you see the sun going over the horizon, the distance of the autumn-spring equinox point of sunset and the equatorial summer sunset. There's a particular distance that I got AI to finally agree could be about 14.4 inches between those two sunset points. And remember, the sun starts, according to them, at 23.5 degrees north on the Tropic of Cancer of the equatorial line. And that, I guess, equates to something like, 1,600 miles or something. There's a certain distance that the sun comes up over the horizon on the Tropic of Cancer. So that Tropic of Cancer on the grid is a certain distance from the equator. And so if we're standing there and the sun's above us, then if it's summer, that sun is, then we should know that the sun is north 1,600 miles. And therefore, if it's 14.4 inches between the setting suns, we should be able to count and figure out the distance. And indeed we can. I'll show you the results here. It turns out to be about 5,000 or 6,000 miles, which interestingly enough happens to be the radius of the Earth according to them. However, if there was a curvature of the Earth, we wouldn't be able to see the sun setting, and yet we are seeing the sun setting. So I don't know if any of that made any sense to you. But let's go from there, because I honestly don't think I could explain it much better at this point. Let me just show you what I asked AI and what they kept saying to me. To start with, it sounds like they're trying to hide this from me. It sounds like they were going around and around with me, making up nonsensical statements like, you can't do that. That's impossible. You're not allowed to have that measurement. We're not going to calculate the apparent right distance, because it isn't actually that distant. It's actually the same distance, as it was. It's just that in your eyes, because of this phenomenon where everything goes to converges in the distance, it looks smaller, but it's not. So they would never tell me what the apparent distance would be. It took a long time for me to figure out how to ask that question where they would be forced to answer me. And by the time I got to the end of this, which I believe I'm going to have to do more investigation, and probably if anybody watches this, they're going to go out and do their own calculations. If we can find a mathematician somewhere, or a geophysicist or something, maybe we could get a better answer, because I'm certainly no mathematician. But just with simple arithmetic that even I can understand, and with AI giving me the supposed geometry, and the calculations, let me share with you what they say. So I say, if two straight lines on the Earth's grid, one starting from the point of the Tropic of Cancer and the other at the equator, were to extend to the distant point of the place of convergence of our eyesight, how far would the point of convergence be in the distance from our eyes? And they say the premise of the question is not scientifically possible to resolve, because the human eye can only achieve a point of convergence for objects that are relatively near, not on a global scale. For distant objects, such as points on the Earth's grid, the eyes are in a relaxed parallel state, and the concept of convergence is not applicable. Well, honestly, I have no idea what they just said there. It's not applicable. What is what are they saying? It's not applicable. I'm thinking, wait a minute, it looks smaller in the distance. So just tell me the apparent distance. We can't do that, okay. So it says the limits of human eye convergence, near point of convergence. The maximum convergence of the human eyes is for objects that are very close. I'm not really following this, but an optometrist tests this near point of convergence by moving an object toward a person's nose until double vision occurs. Typical convergence distance, the normal near point of convergence. You know what? To save time, I'm going to blast through all this bullshit, because they're just trying to make a lot of excuses here. But let me just go to some points that they make that are going to be relevant to what we're asking. Then they mention that the Tropic of Cancer is located 23.5 degrees north latitude. The distance between the Tropic of Cancer and the equator along a line of longitude is approximately 2,600 kilometers, or 1,615 miles, which is my point of reference, because I use miles. I'm an American, thank you very much. I don't know what these kilometers are. But anyway, 1,615 miles, which is a long distance. And it says this immense distance is not only far beyond the limit of human eye convergence, but it is also a global scale that has no bearing on the function of an individual's eyes. Oh, great. What are you saying? Has no bearing on the function of my eyes. Well, the question conflates a human physiological limitation with a geographical feature on a planetary scale, making a definite answer impossible. So basically, they just gave me a big F-U and said, have a nice day there, son. I would think they would go, oh, wow, we're so smart. We're AI. We know what you're getting to, what the point of this is. And it's a very great point, and we've never thought of it before because we're stupid. But wow, let's think about this. What you're really trying to say is, how does any of this make sense? If the Earth is only 24,000 miles around, 12,000 miles from pole to pole, 8,000 miles diameter, 4,000 miles radius, then how does any of this math make sense? Because supposedly you're saying the horizon is just over just over there. The sun would go over the horizon in just a few miles, like 50 miles or something away. It's supposed to, well, I don't even know. Maybe because the sun's so far away, they would say, oh, it'll go further. But we can't see over the horizon supposedly over just a few miles away. So then you start thinking about that. If we can't see over the horizon, and our horizon from where we're standing 6 feet tall, right, at an elevation of sea level, is just going to be a few miles in the distance, and how in the world are we seeing that sun up in the sky for, like 12 hours a day and finally going down over the horizon? None of this math makes any sense with the information, at least apparently in my mind. So I'm trying to come up with this, and they're like, nah, it's impossible. Forget it, young man. You're a nice, big, strong little chickadee, and you're going to grow up to be a rooster someday, but you're not going to figure this out today, because we're not going to let you have that satisfaction. We're just going to play stupid. So I'm like, okay, I'll play stupid. How about this question? Ha! So, doesn't the mountain 10,000 feet high appear to be about 1 inch high at a distance of 50 miles? How far would it be mathematically for the two parallel lines to appear 1 inch apart to our eyes looking at the horizon? I hope you guys are following this, because A, I can't, but I think most of you could. It says to calculate how far away an object appears, we can use the concept of angular size. Angular size is the angle an object appears to span from the observer's perspective, and it's inversely proportional to distance. First, we can verify the estimate that a 10,000-foot mountain appears 1 inch high from a distance of 50 miles. We can use the small angle approximation, which treats the situation as a right triangle, where the distance is the adjacent side and the object's height is the opposite side. Oh, I think we're talking about geometry here. The angular size, and then there's a lot of calculations that my mind just goes bleep, so I don't even want to see that. Just give me the conclusion now, Spock. To find the apparent height at a different distance, the distance of your arm, for instance, you can rearrange the formula. Thank you very much for that, allowance. But assuming your arm length is about 2.5 feet, 30 inches, the apparent height of the mountain at arm's length would be 1.14 inches. I said 1 inch. I was off by 0.14. So, and that was just my, estimation. I didn't actually calculate it, but I turned out to be right. So the initial estimate is reasonably accurate. Thank you. Give a little hand for David. Yay. No standing ovations at this point, friends. Wait till the end, okay? And then you may bow. So distance for two lines to appear 1 inch apart. To find how far away two parallel lines of a certain actual width would need to be to appear 1 inch apart, we use the same principle but reverse the calculation. The question at the horizon complicates this, as the true horizon is based on the observer's height, distance. Instead, let's calculate for a flat plane. Yay! They can't do it on a globe. So we'll use a standard visual angle as a reference. The human eye can resolve an angle of about 0.00029 radians, or 1 arc minute. I don't know if any of you know how far an arc minute is, but boy, you must be some kind of genius. But anyway, it says for an object to appear 1 inch high, it would need to span a specific visual angle. Let's work backwards to find the distance. Oh my goodness, I'm dyslexia here going on. Backwards now, you say. Okay, we'll use a variable for the actual separation of the lines. Let's make an assumption for the apparent separation. Shall we? Okay. We shall. Assumption number 1. The eye cannot actually measure an apparent distance of 1 inch at the horizon. The calculation depends on the distance from your eye to a reference plane. Oh, let's go on. Continue. You've got my attention now. Using a small angle approximation, again, the distance from the eye is blip, blip, blip. And we can rearrange this. Let's rearrange it now to solve for the distance. If the lines are 100 feet apart, for example, the distance for them to appear 1 inch apart at a distance of 2.5 feet, your arm's length, would be 3,000 feet. So, for parallel lines 100 feet apart to appear 1 inch apart, they would need to be 3,000 feet away. We're getting somewhere. To make an accurate calculation, we need to know the actual separation of the parallel lines. The phenomenon of parallel lines converging to the horizon is a matter of perspective and not fixed mathematical point. The calculation depends on the line's actual separation and the observer's visual acuity. Wow, such big words, my maestro. Let's see. Let's go down here and let them have the next question. So what's the distance of the appearance of 1 inch if we are talking about the sun being on the Tropic of Cancer in the summer and simultaneously another sun being on the line of the equator? Please just give me the answer. Well, they say, no, we can't do it. It's impossible. The premise of your question is based on a scientifically impossible scenario. There's only one sun in our solar system, you idiot, and it cannot be positioned over the Tropic of Cancer and the equatorial simultaneously. Oh, well, then I guess we're just out of luck, because it's impossible. Because the sun can't be in two positions at once. But what if, just what if, if you just say, in this little fantasy equation, they even do fantasy football. I think we can do fantasy science. But let's just imagine then that there's two suns. Or better yet, if it satisfies your little AI brain, why don't we say if there is 2 points? Forget the sun altogether. But we just have these 2 points, one at the Tropic of Cancer and one at the equatorial point. Then what would be the conclusion of this little treatise, of this little calculation that we're postulating? So they go on to say, a bunch of nonsense. Your question appears to be continuation of the previous discussion about the apparent size of a distant object. I mean, who's writing this? AI? I think it's the devil. We can use the same principles of angular size to address the question as a hypothetical thought or experiment. Yeah, that's what I was trying to say. But, they can't understand all this. You've got to be very specific with this AI. If we were to assume that there were two objects of the sun's actual size at these two locations, then the calculation would be as follows. Oh, thank you. Finally, we've gotten through all the riffraff, and we've gotten down to the actual question. So first, we'll need to know the distance between the 2 points on the Earth's surface. The distance between the equatorial and the Tropic of Cancer is 23.5 north latitude. It's approximately 2,600 kilometers or 1,615 miles. To calculate the distance at which this separation of 1,615 miles would appear to be 1 inch, we use the small angle approximation. We need to determine the angular size. This distance would subtend and, wow, what a word, subtend? I don't even know if that's a word. And then find the corresponding distance from the observer. Well, the formula for distance based on angular size is this distance equals actual size, and that's over the angular size. If we assume the apparent size of the two suns to be 1 inch apart on the ruler held at a distance of 2.5 inches or 25 inches or whatever they're going to say here, 25 inches, a typical arm's length and angular size is and now we can calculate, and from the observer for the two locations to appear to be 1 inch apart at a distance of 25 inches. They couldn't just give me the answer, right? They had to go through all this. Using the distance between the 2 points on the Earth, 1,615 miles, or approximately 8,525,200 feet, right? Anyway, this approximately is 40,000 miles. However, this calculation is purely theoretical exercise and does not account for the curvature of the Earth or the physical limitations of the human eye. Well, what's really crazy, as I'm thinking about this already so far, and we've got a little more to go here, but maybe we're just, don't get excited now. Maybe we're wrong. Okay, I don't understand this really. So I'm going to keep asking questions till I do. So the 40,000 miles is how far away 1,615 feet with two parallel lines going in the distance, extending those two parallel lines 40,000 miles, they would appear to converge or be on the road of convergence, but not yet actually converging. But now I want to know, what would it be if we go closer to convergence, like a fourth of an inch? And so I say, now do the exact same calculation, but only one variable different. In this scenario, instead of 1 inch, how far would it be for our eyes to perceive the point as 1/4 of an inch? Okay, so what we've got so far is they're saying that it would be 40,000 miles where something that starts on two parallel lines 1,615 feet apart, extend those two parallel lines out in the distance until they appear to be 1 inch apart, would be 40,000 miles. So I decided, well, I would like to know how far it would be to convergence. But they keep saying there is no convergence because it's just an illusion, so they won't do that. I got to have a specific calculation for them. So I said, how about if we didn't make it an inch, we just made it a fourth of an inch? Because you could go to a 16th or a 32nd or 1/64 infinitely. So we could never find the point of convergence because it's an infinite convergence. You could go into fractions. So I'm just going to use 1/4 of an inch and see what the answer is. So now do the exact same calculation, but only one variable different. In this scenario, instead of 1 inch, how far would it be for our eyes to perceive the point as 1/4 of an inch distant? And then they say this is a continuation of the hypothetical scenario based on a physically impossible situation. As established previously, there is only one sun, so it cannot be simultaneously positioned over both the Tropic of Cancer and the equator. However, don't you think this is a little condescending and sarcastic and behavior that you might get from a person or the devil and not a machine, right? I don't know. But it says, however, we can perform the requested calculation as a theoretical exercise, thank you, based on the principle of angular size. Calculation for 1/4 inch apparent distance. The inverse relationship between an object's distance and its apparent size means that if you want something to appear smaller, you have to increase the distance. 1/4 of an inch is a 1/4 of an inch. So the distance will need to be 4 times greater than the previous calculation. Step 1, recap the previous calculation. We came up to 40,000 miles, right? This was calculated by first finding. So step 2, adjust for the new apparent size. To find the distance needed for the separation to appear 1/4 of an inch, we can follow the same steps. And we come out to, well, the conclusion is, for the hypothetical scenario of the objects with the sun's apparent size and positioned over the Tropic of Cancer and the equator, the observer would need to be 161,500 miles away from the separation between them to appear as 1/4 of an inch apart. The result makes sense as the distance is exactly 4 times the previous result of 40,000 miles. This confirms the inverse relationship to make an object appear 1/4 as large. You must be 4 times further away. So 4 times 40,000 is 161,000 miles. 161,000 miles, and yet the horizon should go down just a few miles away from us. And maybe because the sun is so far away, like 93,000 miles, it's going to appear to be not going over the horizon yet because it's so high in the sky. Okay. Assuming that the Earth is a globe. But what would be the actual, if it was an infinite plane, we would literally be able to see the sun converge, apparently, because it would appear to be converging, probably even at 40,000 miles, right? Because 1 inch, the sun's bigger than an inch, probably at the horizon, maybe. And so the adjustment, 1 inch, would almost be like a convergence. And I don't know if you could see the sun 40,000 miles away, through the atmosphere of the Earth. I guess you could. You should be able to, right? You should be able to because it's so bright. But it would get smaller and smaller and smaller, and maybe with a zoomed lens or whatever, you could probably see it at 161,000 miles, which is not that far away from what we claim the moon is distant from the Earth, which is 240,000 miles. So we can see the moon 240,000 miles away. We should be able to see the sun 161,000 miles away. And though it's not in convergence, we could do the same mathematical formula that they just did, and we'll say that 1/4 is 1/4, and therefore we have to times the 40,000 by 4 and get 161,000. Let's do it again. Let's say 1/8. That's 50%. So now we've got 320,000 miles away. If we wanted to converge down into a 16th of an inch, we'd have 600 and 700,000 miles away, 720,000 miles away or something. If we could go down to a convergence or apparent convergence of 1/32, it would be 1,400,000 miles. And I don't know if you could even see the sun at that point in the distance because it would be such a small little point. I don't think you could see it. Probably somewhere before it gets that far away, you wouldn't be able to see it. Not because it went down over the horizon, just because it would just be a speck, and you wouldn't notice that little light just in that little small speck. So that's some calculations there. And the fact that we can see the sun in the distance just immediately just drop like it's going over the horizon. And we don't see the sun getting smaller and smaller and smaller and smaller and smaller and smaller. But it just seems like real quickly the sun goes from being a big round ball on the horizon to go gone. So what's up with that, right? So we got to add that to our equation. But now let's go on. When we see the sun go down over the horizon on Earth, in summer, when the sun is in the Tropic of Cancer, does it appear to go down at the same point in the period of that time of year when the sun is in the equator? If it does not, what is the distance it appears apart from the other at the horizon? And they say during the summer, when the sun is positioned over the Tropic of Cancer, its sunset point on the horizon does not appear in the same place as it does during the spring and the autumn. When the sun is over the equator, the specific difference depends on the observer's latitude. Anyway, with all their nonsense, they go on and on and on. They say the previous calculations you requested regarding the 1 inch or the 1/4 inch apparent distance cannot be applied to this situation because the horizon is not a fixed nearby object. The actual physical distance between the sun's position in the Earth's orbit is immense, but the apparent distance is measured in degrees of a circle. So they're saying, yeah, we can't give you the answer to that. And I, again, believe that they're obfuscating. I think they could have given me an answer. I think they knew what I meant. Maybe they're technically correct. I didn't give them enough actual math to be able to do it. But they seem to know what I'm thinking half the time. So you would think they would have just went ahead and supplied that extra figure and gave me the answer, the apparent, distance. But they didn't do it. So I said, so how far separated is the two suns at a horizon in inches? And they say, well, there is no single answer in inches because the concept is mathematically and physically nonsensical. I didn't think it was nonsensical. You gave me the answer for 1 inch. Now I want the answer for 1/4 of an inch. And now it's nonsensical. And then they break it down, blah, 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 and it's just ridiculous, right? Stuff that they just round and round and round trying to tell me that it's impossible. So conclusions, no inch measurement possible. All right, let's give them another question. If you were on a flat desert area with no mountains near, the sun would be on the horizon as it set. In the summer, it would appear in some apparent spot. How far apart does the spring or autumn sun set away from the summer setting on the horizon? Your questions have been exploring how to translate the apparent angular, see, they know what I'm thinking, angular separation of the sun setting point on the horizon into a linear distance, measured in inches, as previously explained. This is not possible because the sun is not a nearby object and the horizon is not flat. Okay, but what if it was? Oh, what if it was? That's what my question is. The change in the sunset's location is measured in degrees, and this angular separation depends on the observation location. Here's how to describe the difference, and then they go on with another bunch of nonsense. And it says why the inches are not valid, and da-da-da-da. In summary, the distance you're trying to measure is an angular one, not a linear one. In a flat desert, you would use a compass to measure the degrees between the sunset. Duh, okay. But I don't want to use a compass. I want to know the apparent distance. They can't do it. They can't do it. They just can't do it. So I asked them another question. Yes, you're perfectly right, AI. Oh, master. Oh, you're so wonderful. You're so smart. But the setting points would appear in the distance to the observer as some apparent distance apart. At that distance, the sun may go down in autumn at a mountain peak on the left side of center vision, while the summer, it will appear further south at the elevation of sea level. How far approximately would the two setting points appear distant from each other on the horizon? I think I've made my point perfectly clear. What is your answer? And they say, even on a flat desert, you cannot measure the distance between the two sun positions in inches on the horizon. The horizon is not a surface. It's the furthest point you can see in any direction, and its distance depends on the observer's height. The two sun positions on the horizon would be separated by an angular distance, not a linear one. On and on and on, and so why you can't convert this to inches, and so it's a big fat no. However, I'm going to keep on with this because I'm pretty persistent. So I say, okay. So if I hold up a ruler 2.5 feet away from my eyes, what measurement on the ruler would the two setting suns be? Based on your request, here is a calculation of the apparent distance between the summer and equinox setting points. Well, that's what I asked you before. God! On a ruler held 2.5 inches from your eye, this assumes a reference point of 40 degrees north latitude, such as New Mexico, to use the angular separation calculated previously. Calculation for 40 degrees north latitude determined the angular separation for an observer at approximately 40 degrees north latitude. The sun sets due west during the spring and autumn equinoxes. At the summer solstice, it sets at its northmost point, which is approximately 27.6 north due west. Angular separation equals 27.6. Convert the angular separation to the radius, blah, blah, blah. And what is the answer, my dear friend? Well, result. For an observer at 40 degrees north latitude holding a ruler 2.5 feet from their eye, the apparent distance between the equinox sunset point at the summer solstice sunset point would be approximately 14.4 inches on the ruler. Yay! But no standing ovation yet, please. But we will give a little yay, because that's really, really, really getting somewhere, that we got AI to even give us that much. So this calculation is a useful mental model for visualizing the angular shift of the sun over the seasons, even though it is not a literal measurement of a physical distance on the horizon. Well, of course, if you believe there's a horizon, or, if you believe that the earth is round or flat or some other specific, concept, and you're going to go from that basis. And therefore, in your little mind, it's not possible. But what if? And that's what I'm trying to get at. So I have another question. If the apparent distance between the two suns setting is 14.4 inches, how many miles from the reference point of my eye in New Mexico, 40 degrees latitude at sea level, me being 6 feet high, would the distance be from me to the two setting suns' apparent separation? I don't spell very well when I'm excited. So just calculate how far two lines starting at 23.5 degrees apart on the Earth as a globe, 12,000 miles from pole to pole, how far away would these lines, now apparently 14.4 inches apart, be from the observer in New Mexico in miles? Oh, but it's not possible to calculate a single fixed distance in miles for this scenario. The question contains a fundamental misunderstanding of celestial mechanics and visual perception. The flaw of the premise. Your question is based on a flawed premise combining two incompatible concepts: the sun's real position and the angular separation. The sun is a distant celestial object. Its apparent movement across the sky and along the horizon is a matter of angular changes, driven by the Earth's rotation and the actual tilt, and how much you've had to drink that day. I mean, I guess. The sun's path during the summer over the Tropic of Cancer, over the equator, are astronomically distant and are perceived as an angular shift on the sky and not a linear distance. So the calculation is impossible, egghead. Doesn't exist. Two suns don't exist. Blah, blah, blah. Okay. So the correct interpretation is blah, blah. It's 27 degrees. All right. I've got another question for y'all. I'm getting down to the bottom of the barrel with these questions because you just don't want to answer me. But we're going to try it again. I'm going to say this. I'm asking for an approximate measurement for the apparent distance of the two suns setting at some distance. I would like to approximate from my specific point in New Mexico. As stated in the previous response, it's not possible. All right. So we got another question. I mean, I'm running out of questions, but let's go here. We might get somewhere here in a second. So to transfer the calculation to a person on an infinite plane to a place of the apparent convergence of 14.4 inches, where the two suns or points of reference will call suns, starting at 23.5 degrees apart, as measured in miles on a globe, but in the scenario on an infinite plane. How far is the distance of the two suns apparently 14.4 inches apart on the plane ahead? It says your scenario is now involving transitioning from a spherical Earth to an infinite flat plane and asking for a distance in miles where the angular separation previously translated 14.4 inches on a ruler would be achieved. The 14.4 inches is the apparent separation on a ruler held 2.5 feet 30 inches from your eyes. To convert this back to an angle, we use the formula blah, blah, blah. Now, here's the infinite plane. The problem then becomes, on an infinite plane, how far away would 2 points representing the sun or the sunset points need to be for them to appear 14.4 inches apart, equivalent to 70 or 27.5 degrees of an angular separation? To solve this, we need to know the actual distance between the two suns, or reference points on this infinite plane. You stated that the points are starting at 23.5 degrees apart, as measured in miles on the globe. On the globe, with a diameter of 12,000 miles, meaning a radius of 6,000 miles, keep that in mind, the radius is 6,000 miles, an angular separation of 23.5 degrees corresponds to an arc length distance on the surface of the globe. The circumference of the globe is 23.5 degrees separation would be 37.699 miles. This is the actual distance between the sun's position over the equator and the sun's position over the Tropic of Cancer on the surface of the Earth. So calculating the distance. Now we are treating these two fixed points on the infinite plane that are 2,460 miles apart. Oh, buddy, we got somewhere. The two fixed points on an infinite plane are 2,460 miles apart. We want to find the distance from an observer on this plane, where these 2 points appear to be 14.4 inches apart, or have an angular separation of 0.48 radians. The conclusion, therefore, in this highly theoretical scenario, if you are in or on an infinite plane, and there are 2 points 2,460 miles apart, you would need to be approximately 5,000 miles away for those 2 points to appear to be 14.4 inches apart. On a ruler held 2.5 feet from your eyes, this calculation relies on the fictional premise of two suns existing simultaneously and an Earth transformed into an infinite plane. Well, what if the Earth is an infinite plane? Then, in that case, we would calculate that this thingy up in the sky that's not 93,000 miles away, and the globe not being a globe but an infinite plane, then we would be standing on an infinite plane watching this big ball go way out to a distance of 5,125 miles to get the appearance that we get, where the two setting suns in the autumn or in the summer are that far apart, 14.4 inches, which is what we actually see. We see the sun setting in the summer 14.4 inches away from where the sun sets in the spring, which is 1,615 miles times 2, making it 2,460 miles apart, because you've got the Tropic of Cancer, which is 1,600 miles to the equator, and then from the equator to the Tropic of Capricorn. So those are the two parallel lines, Capricorn and Cancer, that somehow at different times of the year the sun sets in the distance 14.4 inches apart on our horizon. And that would be, according to these guys, if it was an infinite plane, that 14.4 inches would be 5,125 miles. And here's the crazy part. Remember that 6,000 miles radius that I wanted you to remember? So if you're standing anywhere on the Earth, let's say you were standing on the equator and you were looking south, you would literally have 6,000 miles to the pole. 6,000 miles to the pole, which is what they claim, that's how big the Earth is. 6,000 miles from wherever you're standing to the pole. But you couldn't go all the way to the pole. If it was an infinite plane, we would only be able to see to the wormhole, or where the figure 8 converges. That's something we're going to talk about tomorrow, because I'm going to talk about convergence from all 360 degrees of the circle in every direction. 360 degrees times 360 degrees, an infinite universe. But we're seeing it as a globe because it all converges 5,125 miles right at the ice wall. Whoa, buddy, that just works in the known realities that we have. We know the supposed distance it takes a boat to go to the ice wall from the equator is 5,125 miles. Bam! And it fits the exact mathematical measurements that we've used. So, I think since we're over an hour, I'm going to leave it here. But I do want to say that you should watch tomorrow's video. If I can do it tomorrow, hopefully I'll finish this tomorrow. Because tomorrow I want to say, we're going to take this entire discussion way further. Today we've just been trying to figure out where two lines, parallel lines, meet and converge. The up and the down, the horizon, it all meets at the horizon. And tomorrow we're going to investigate if all of our reality, not just up and down, converges at the horizon, but all of our reality, left and right, and each degree in our peripheral vision, which is a sphere, were to be calculated, it would, as we stand there, everything in our reality, in that peripheral vision, would come to a point like a cone, or perhaps like something like this roundness. Maybe it wouldn't be perfectly round. Maybe it would be wide at the base of the cone, which is the equator, and maybe that apparent cone is just why we perceive the Earth is going out of sight, like at the poles or over the horizon, if you understand what I'm saying. Now remember that you'll be able to turn your head 1 degree and there'll be a whole nother 360-degree peripheral that also would converge at a point. And therefore, you could go around in 360 degrees looking in any direction and everything would converge at a point. And therefore, what would you have? A circle. And therefore, our reality at any given point would appear to be a globe-like thing, except that if you were to travel the 5,125 miles, get to the ice wall, climb up on it, and go all the way to the point where the 6,000 miles radius would end, you'd actually still be on a flat plane that you could not have ever known was there, would not be observable to any of us because we're all up here on these floating continents, and we're all looking down there, and it's converging, looks like a round thing. No one's ever gone to the South Pole. And if anybody has gone, with the Nazis or something, they ain't going to tell us what they saw. I believe there is a wormhole, and another way of looking at it is it's an infinite plane. But for those of us in our reality, our perception is, because we can't get to the South Pole or the North Pole. No human can do that without modern equipment because it's 70 below zero. And if you got on a boat and went there and you took a skidoo, how would you take enough gas for the skidoo and the engine would freeze up in that cold weather? You wouldn't be able to go there. So no man's ever gone there and witnessed this infinite plane, except for maybe Admiral Byrd, which that's a rumor, right? But doesn't even we can't confirm that. I have also read about some guy named Hansen that did expeditions to the North Pole and the South Pole, and there were others that supposedly took a boat down there to the ice wall back in the day, and there's always been people looking around, but almost no one's ever just walked to the supposed South Pole. I believe that these figures, 5,125 miles, seems to fit pretty well with the apparent miles and distances that we have. And so that would mean that there is not, a real globe, but only an apparent globe. Anyway, I'm going to leave it there. We'll talk about this again tomorrow. Hope you guys have a wonderful evening. The Lord will bless you, and His grace and His peace will be with you. Just believe and seek Him. We'll see you tomorrow. Have a good one.